So I think it's interesting if you look at the panel that we have here, you've got John Paul from Condé Nast, which was founded in 1909 as the publisher of Vogue, and obviously has many other titles to name. And Lindsay talked earlier on about how Condé Nast is changing from being a media company to a publishing or to a technology company. And then following on from that, you've got Katie from the BBC, who was incorporated in 1922. So both of these organizations have a lot of what we might call legacy, both in technology terms and in terms of their industry. And then you've got Yunong Xiao from Netflix, which is like the new kid on the block, 1997. I mean, that just seems like yesterday. And Netflix has most definitely started out pure and simply as a technology company. The core of what they do is technology. Even I am still astounded to this day by the way that they can vary the resolution of the screen to ensure that the connection keeps up. And so we see a lot of talk about how microservices are coming out of the labs and going into the real world. And so the question I put to the panel as a very first start of it is microservices making you faster? Or is it just the fact that you have great teams and no matter what you did with them, you'd be faster? John Paul, you haven't spoken today yet. I'll land that one right at your lap.
Okay, that is true. So, hello. So microservices by themselves, I don't think are nearly as impactful on pure speed as the sort of organization and modularity that are forced upon an organization when using microservices. Does that make sense? So it is not necessarily that because we happen to split up code into web APIs that call themselves through HTTP that somehow we are faster. But because teams can be mapped more effectively to code bases and let's say business units or different work tracks, that is where the speed, I feel, has come from in terms of actually shipping code.
Okay, Katie, you've got as much legacy as anybody in this room.
So yeah, I think that what John Paul was saying is true. Good teams, good communications, and the ability to break down the work into small-sized pieces is great. But I do think that in terms of what we're working on, just the deployment process has sped up because of using microservices, because we can spin up a new microservice in a month if we need to that will do a job that we need. So yeah, and we can test that, and when we have the confidence in it. So yes, I think it's a combination of the two things.
Right. When you say spin up a microservice in a month, does that mean we think about a new microservice, we write it, and we deploy it in a month? Or we have a microservice that we decide to deploy, and it takes a month to deploy?
No, we think about a microservice, we define what it's going to do, we get it out, and we're using it in a public-facing way in a month.
That sounds pretty fast. Yunong, the new kid on the block. Okay, Netflix. All problems can be solved with Netflix technology.
Well, I think the biggest thing to remember is that just because we're founded in '97, it doesn't mean we don't have any legacy. Actually, most of our platform teams are in the middle of this big transition from a very monolithic data access tier to something that's made up decomposable with microservices. But I think at the end of the day, what microservices really give you is the isolation, both in terms of the service itself, but in terms of like the service-oriented architecture and that contract, and as well as in terms of the people that own that service. So that now, instead of having to push the entire monolith all the time, you're just pushing individual updates to each microservice. And these teams are isolated from each other. So service team A can change their service as long as they respect their service contract. They don't really have to wait around for anyone else to coordinate with. And that lack of coordination, I think, is sort of the central tenet that helps businesses like Amazon or Netflix really be more efficient and sort of have higher velocity, right? So that's
okay.
Sorry.
No, go ahead.
So I'm sure it's been discussed already here, but like all of this depends on each of our internalized definition of microservices. Because I agree, like if you had that, if there are exact contracts between teams and those teams also own APIs, that there is significantly more than like marginal changes that can happen because of this organization. But I feel like depending on what you mean by microservice, there could just be lots of APIs and overhead to call basically a distributed system with lots of overhead in figuring out, overhead mentally for engineers to figure out like where messages should go and everything. Having good infrastructure to support those kinds of things.
I think generally where a lot of companies, newer companies without a lot of legacy find themselves in their first cut is, let's go with a microservices-based approach, which is great. And now you have, 10, 15, 20, 35 teams running microservices. But at some point they realize that, wow, if I'm a customer of all of these microservices, it's really hard for me to use them because now I have 35 microservices. So what ends up happening, this is pretty typical across tech companies, is they have this unified middle tier which kind of brings all the microservices together and make them available via one API. And so you have this central integration point. And you see folks leaning towards doing that and sort of creating an API for their entire service and using technologies like GraphQL or Falcon or whatever, where you can unify and easily sort of define what an API looks like. And that team is responsible for integrating all the different microservices that make up your system. So you're still getting sort of the individual teams that own these microservices, they can still move at their own velocities. But you also have this centralized tier that helps to do all of the coordination, which really I think has been helpful for us and for a lot of other folks who are in the same sort of space that we are.
So how does that work out in practice? Do you end up with a queue of people waiting for that team to integrate their services?
That's a really good question. So generally what happens is, you generally have a back end, right, with a bunch of microservices teams, and then you have a set of front end teams who own all the clients out there. And at some point, the front end has to meet the back end. So you end up having this middle tier, which are kind of like gatekeepers of the API, so to speak. And so yeah, like if you need to integrate new changes into your back end microservice, what you're now doing is you're decoupling that change from your client teams who need to consume your data through this middle tier. And so they're all working with each other in concert with this integration point, which is the middle tier, which helps with velocity on both sides, right? Because your client teams can feel free to innovate, knowing that the API is somewhat stable, and your backend teams can also innovate and change what their service looks like without having to drastically change their API because there is that integration point.
But is that not really just changing effectively the performance characteristics of the service without actually changing the service itself? What happens if you want to add new API calls or new capabilities that the clients can consume? Yeah. Are you not delayed in your deployment cycle by the fact that there's 50 projects in front of you also trying to integrate?
So yeah, that's a really good question. So what we've done at Netflix and a bunch of other companies do this as well is they basically have, again, back to the platform as a service model. For their front end teams, they provide the ability to write their own APIs using a platform as a service model that is hosted by some other team, right? And so you as a client team can sort of author your own APIs on your own business logic, because at the end of the day, what you're doing is you're taking certain elements from the back end, right? Maybe I need to do some A/B testing, and then I need to go grab some recommendations, and then grab customer information, and then sort of mutate that and change that, and then send that back out to my client for them to render, right? And so that's kind of the approach and the architecture we've taken, which is that we're giving front end teams the flexibility in effect to craft their own microservices pretty effortlessly, and so that kind of decouples the back end data from sort of the front end clients.
Okay.
With respect to your question around if this team becomes a bottleneck, so we have something similar, although I don't think quite as organized and ideal. We have a team that is significantly involved with the creation of a sort of front-level API that many of our front ends consume without necessarily knowledge of all of the back-end services. It's not necessarily purely microservices, but that team, it all depends. This is just like Semver. It all depends on what kind of things they're trying to add. When adding new features, no one's using those features anyway, so it's very little, if no change at all. It is only when breaking changes happen, right? And as much as possible, that team is, I actually think that in general, that team is focused on making sure that either backwards compatible changes do not happen, or that they are handled extremely gracefully with a lot of thought put toward one, communication beforehand, such that all clients are moved appropriately, as well as if this is something that is considered very risky, making sure that they have very easy fallback and rollbacks in place, such that if something does really go wrong, they can flip it back in 10 minutes. So this integration team, it hasn't been as much of a bottleneck as an enabler to make confidence happen across what could be, I would consider, like a really messy integration point.
How do you guys define legacy? We talked a
Definitely.
little bit about this earlier on.
when I was out, there's two things I found really funny. One, I don't know if you meant the New Kids on the Block 1997 thing, but that was perfect. It was like so exactly right.
That was accidental, but I'll take it.
But no, it was really good. It was really good. I think you planned it. So also, like 20-year-old company being not legacy is very funny. I would say almost all a gigantic chunk of the legacy code I have worked with and myself written was after 1997.
How do you define legacy in Netflix, you know?
I think legacy is, it could be code that you wrote yesterday, right? Like to John Paul's point, it's not really specific to the age of the software. It's really around, is that piece of software or that service relevant and performant and sort of fits the business characteristics? So for us, for our front-end teams who are crafting these APIs on the fly, a lot of their legacy code is stuff they wrote like 6 weeks ago, right? Because it gets deprecated, their clients fit out in the wild and they have new software. I think on the sort of the back end, that's kind of where legacy is a little bit more dramatic in that sense. For us, it was like moving out of the data center finally, right? And we did that 2 years ago. Now we're completely cloud native and things of that nature. The software, you have to remember, is like this living, breathing thing. It's really hard to axe any one piece of it in one hit. Generally speaking, you're creating new versions of the same service to maintain backwards compatibility. We have this sort of ethos currently where we don't stop clients, really old clients, from using the service. So there's clients out there that's on the Nintendo Wii or even older devices where all you could do is browse your favorites queue or whatever, but those still would work, right? And so that's really
pretty legacy.
That's pretty legacy, but it's all your definition of sort of your service contract of what you want to exist out there.
So how long would you keep your long tail going with those sorts of devices?
Currently, we don't really stop any devices from sort of using the service. I think there's been some discussion around, will this continue forever and ever? But that's kind of, we're still sort of debating that internally. But currently, fire up any device from anywhere that's ever had Netflix as a client on that device, and they should still work.
I actually find that to be one of the sort of fundamental, I think there's tons of blog posts about this, but has not yet been solved necessarily anywhere very, very well, which is API versioning. It's not nearly as easy and as easily understood and deployable as like a node module with Semver.
Well, so we've actually done something similar to Semver in our new stack of APIs, which for APIs rather, similar to node modules, is we recently started to Semver our APIs as well, and so we're able to route based on the semantic version of the API, based on the major or the minor, or even the patch version if we wanted to, and that helps clients, helps teams to be able to push out updates to their API without having to worry about breaking other clients out there. And so that's something we've sort of been playing around with. We think we're starting to see more and more services internally start to use that as well.
And do you continue to support every back version?
No, I think what we do is, generally speaking, we have a major version of an API. You have and then you have a bunch of clients that consume that major version. And then if you make a breaking change to that API, right, then you create a new major version of that. And
Got it. So it's only the majors that you.
Yeah. The nice thing about that is also you can push with confidence because you know that, hey, this version, if you push the patch to a specific major version, you know that hey, this major, you're only going to affect that major version, and at any time you can roll that back or forward without breaking all the other clients out there. So it's definitely something that we've been thinking about for a while.
How do you define catastrophic service failure, and how do you handle that? I mean, everybody has had catastrophic service failure, particularly the major cloud providers. We've seen the recent Amazon outage. Azure has gone down. Google Cloud Platform has gone down. Every cloud service I've ever used, including every internet banking service I've ever used, has been down for days at a time. How do you define catastrophic failure? Because that's obviously a very signal event. And how do you handle it and recover from it?
I think it's critical to realize that any failure could be catastrophic if you're not architected for it, right? So if I think back 3-4 years ago when we went down during the Christmas break because there were some Amazon ELB issues, right, in a specific region, and that took down the entire service. After that, we started thinking about, can we make the service sort of region independent? So we started playing around a lot more with regional failovers, and we actually exercise those on a routine basis and practice failing all the traffic out of all 2 of our regions into 1 region and things like that. And you really see that help us in terms of what you would call catastrophic outages, which is core pillar of the internet, like S3 going down for a morning or entire day where the entire internet is screaming because everything is down. But ironically, we were able to stay up, and that's because we sort of planned and designed the architecture around the fact that, hey, all the different regions that we have in the world on the same cloud provider, we can just shift that traffic away. And so that's what we did. We filled traffic out of US East into, I forget whether it was EU or US West. But being able to do that and having a team that owns all of that, that playbook and running regular exercises to actually fill all the traffic out of a specific region, even when you don't have failures, really help. But the key thing to remember is like any little thing could cause a catastrophic failure, right? It doesn't have to be AWS being available. It could just be a bad code push. We've had catastrophic failures where someone's accidentally deleted all of the API endpoints, right? And then we were down. And so I think the critical thing is understanding that you will have catastrophic failures, but whenever you have them, always root cause them and then figure out what you're going to do to prevent that from happening again.
Katie, can you talk a little bit about your experience of catastrophic failures in the BBC? Although I've never seen the BBC website down, I have to say.
We have graceful degradation of service. So we have great caching, so we've got a lot of varnish in front of stuff. So we are able to serve up old content if need to, and we will serve stale as long as we can. So meanwhile, in the background, everyone's running around.
Right, okay.
So, yeah.
So what do you do to respond? So when you see a failure or when you have a failure that you haven't anticipated, how does the BBC kind of playbook that to make sure it doesn't happen again?
Again, we have ops tickets that will be alive throughout the route of the failure, and then there will be a root cause analysis on what happened, and we will attempt to put in fail-safes to ensure that if we see a similar thing in the future, we have a way of gracefully degrading in a different way that will make sure that we stay online.
What about Condé Nast?
Similar, I think, things to the BBC. So I think media companies of a certain type have a huge luxury in that of CDNs, such that this. So I mean.
Unless your CDN fails, right? So
sure. Yes.
Yes.
There's always going to be failures.
Yes, completely. But I think in general, CDN catastrophic is this word that, again, in some sense, it could be when your CEO calls you, or like if the CEO calls you, right? Like so for actual system failures, we have typically and often for the acute problems relied on CDNs. But similar approach to the BBC, we have people behind running around trying to figure out how to actually quarantine and successfully prevent next time after the fact. Mm-hmm. But I can't think of, there are many situations, all of them have been successfully handled. I would love to get to the state where we are doing things like drills and preparing for where, although a lot of these cases, microservices aren't particularly involved, or it's not particularly about microservices. It's about our infrastructure in general and how our architecture in general handles this kind of thing. And how monitoring we have missed something to monitor that we could have caught beforehand. I think that's a pretty.
It's also like a cultural thing, right? I think, like for example, every service that goes out to production Netflix that's in the runtime path, which is like if it's involving a customer making a request, it has to go through a production ready checklist. And you have to go talk to the SRE team and the performance engineering team to make sure you have all the dashboards and metrics in place, right?
That's a big one. Metrics and that,
And the other thing is, I think we've invested in a lot of technologies that we've developed in-house around like failure injection testing. So like testing for failure. I mean, I'm sure people have heard of things like Chaos Monkey and things like that, where we have these agents that go in and just deliberately will just kill instances or kill an entire cluster just to see what happens. And so sort of having that culture of just designing for failure, understanding that at every single layer in the stack that your software operates, something could go offline, right? Your CDNs could be unavailable, your cloud provider could be unavailable in a region, your data could be unavailable, someone could have pushed back code, you could have a client issue, and sort of how do I go about figuring out how to fix any of these issues, and while maintaining uptime if it were to happen. Because the biggest thing for us is, people trust us to give us $10 a month or whatever it is for our service, so we have to make sure that
$20 a month. Last time I looked.
$30 a month. But I think
office space. He's taking off $10 off the top every single month.
Yeah.
Discounts for all the family.
But I think the biggest thing is, you know, making sure that you are available in the face of failures, and sort of it's not good enough for you to tell your customers like, hey, look, the rest of the internet was down. That's why we weren't available.
Yeah.
That's not, you know, it's not really acceptable for our customers.
So you're all king for a day in your respective organizations. What's the one thing you would change to improve your time to market performance?
I think that's something we're already changing at Netflix, which is what I talked about in my talk, which is creating this sort of platform as a service model instead of just using infrastructure as a service. What we've seen is there's a lot of appetite for folks to run their own services, but they're sort of not really, maybe some folks don't have the expertise to run these things in production reliably. So sort of going further up stack to give them the tools and software and the infrastructure and the platform for them to run their own service reliably without having to worry
Everybody
about.
has to use your platform as a service, or they can use their own platforms
Well,
as a
I think the
service?
biggest thing, again, is around commonality, right, and consistency. You know, it's kind of that old Henry Ford saying, you can have any Model T you want as long as it's black, right? I think at the end of the day, we have a very freedom and responsibility sort of culture where you can run whatever technologies that you want, but for a lot of folks and a lot of the teams, honestly speaking, they don't really care what it's running on. They just, like, here's some business logic. Please give me a way to operate and run that smoothly and reliably without me having to invest in my own stack or my own set of, you know, DevOps engineers or anything like that. And we find that ultimately that's saving money for the business and increasing our velocity.
Katie, queen for a day.
I'm not sure, to be honest. I like everything you've said there. I love the idea of platform as a service. We are exploring that sort of idea, but then we have issues around who maintains the platform as a service area. No, I can't add anything.
Within
I'm sorry.
within your own development cycle,
Okay.
resources are uncapped. You can put in what you need. Typically, we don't add more people to make things go faster. But what would you change in your processes or procedures that you think would make life easier or things go faster?
I think that improving our internal monitoring, so we improve our dashboards, improve what we can see for ourselves, improve. I'd like to see. At the minute, we already do regular releases, rapid releases, but it would be nice if at the minute we use a branching system, so everything's on pull request, and then the test team have the ultimate responsibility to push to live. It would be nice if we did a straight through to live deployments.
Okay.
So I think that's probably where we would put our efforts into working on that.
Okay. John Paul.
So I'm on the architecture team. I actually do a lot of thinking additionally around the opposite of this, which is how to put the gates in place correctly such that there is the right things that actually.
So basically, if we fired you, everything would go
exactly
faster.
right. Like, it would be fine. Things would be out. We'd move fast and break things. So it is an interesting dynamic and scale. Like there is a balancing act done that I think some organizations and some cultures have gotten very good at around making sure that there is still rigor to think through things while we are also focusing on our top level priority of shipping. Right? And I mean, we're also trying similar things around Conde building internally a platform such that individual teams themselves can use these tools, use these deployment pipelines such that they can get things out. Figuring out how. So if you gave me the statement you made with like unlimited resources, there's a very unlimited resources means we build a gigantic AI that takes billions of PhDs enough time to like solve it. I don't know if money directly or money or people directly solve this problem. It is much more of like a cultural org thing, I think, and I don't know exactly what I would do if I had all of those resources, but I think we are starting to make those steps to give people the right amount of flexibility. And what I'm thinking a lot about additionally is how to give people the innate restraint, or maybe the feeling of when you're going to fall off the bike when you know how to ride a bike, to make sure that you're not doing things maybe out of the ordinary, even though you would be able to.
So the trap question that I get thrown quite a lot is, what could you do if you had unlimited resources, and I give them a big long list, and they say, oh, give me that in priority order, and you give them number one, they go, well, what would you need to do number one?
I want a genie. I want that genie to tell me what I should do.
Yeah. So, look, this is an incredibly seasoned, experienced panel who are building real-world services. Are there any questions from the audience? Is there anybody who'd like to ask this panel about how they built? There's a guy back there. There's a mic coming. Just hold up there.
So I'd be curious, how of the three of you, how many perform chaos testing, and then details how far up and down the stack do you do it, how frequently do you do it, that sort of thing?
Yeah, we run Chaos Monkey, or Chaos Lambda, which is our version of it, on production. And we don't do things like Chaos Kong. We're not quite as advanced as the Netflix model in that sense. But yeah, I couldn't tell you how often we run it. It runs when it needs to. But yeah, I can usually see the little blips on when it's gone down and how everything recovers.
I think for us, anytime you launch a new service, it's on by default, which means someone has to go turn it off, and it's always running. So I think that gives you an idea of, in terms of like, at least at an individual instance level, it's just always running. There are very few services who would turn that off. And then I think it's about sort of embracing that, and also sort of going up a step further and doing ChaosCon, actively failing out of regions, and practicing those skills. Because those things require our traffic team to actually do a lot of coordination, pre-scaling up clusters on the in a different region, failing things over, and they're active, and they also actively expose deficiencies and bugs with the system, right? And so we very much have the ethos of like, they might possibly impact our customers a little bit in practice, because you might expose some bugs, which means you might have some slight outages, and then you would have to immediately roll back. But practicing this means that you are able to expose those bugs in a non-critical time and then work on them, and also allows our traffic team who handles the major failover, to stay fresh. So they typically do ChaosCon, which is an entire region failover, and they do the whole thing. They'll do it for an entire day. They'll fill out of the region, have it run for an entire day, and fill back. And I can't remember the cadence, but I believe it's on my calendar, so I see it all the time. So it's probably like every couple of months at the least infrequent level. So I do think it's like a cultural thing, though. I mean, if you can't just introduce it if you haven't architected your systems to do that, right? Mm-hmm. So it's really about making sure that you're investing the technology in your stack to be able to handle that kind of failure, and then putting that cultural emphasis on failing.
So some teams internal to the company that are in this sort of more the last category that was just mentioned around being architected in this way do this. But in general, no. There's no coordinated effort across the entire company yet to do that.
Okay. Any other questions? There we go. I'll come back to you in 2 seconds.
So you guys talked a lot about failure testing. I'm wondering if, in the spirit of moving faster and keeping teams autonomous, you guys have any practices you can share related to the testing of the contracts between services, and sort of how teams can move quickly without accidentally breaking one another?
I think key to sort of moving quickly is understanding that in a microservices-based world, you own the software and the service, right? So that means you own the client. So we have a really kind of a different model. Generally, when people think of service-oriented architectures, like, oh, there's a REST API. Just call the REST API. It doesn't use any client, right? And we kind of have a little bit of a different take, which is we expect the teams who own the service to also own the client and own that interaction. Of course, they're building the client with that common platform that the platform teams make available for them. But really, that ownership of updating the service and moving quickly, that ownership is really on that specific team. And so I think once you sort of change that ownership level model, people become very much, they understand like, hey, if there's an outage and it's caused by my service, well, that's okay. We expect you all to learn from that, right? And which is why we have like production ready checklists. We stress testing, and like we do failure injection testing all the way up and down the stack. But understanding that when you move to microservices architecture, you're not relying on that centralized team who manage the monolith for you to sort of pick up the pieces. Everything is on you now, right? You own everything. We provide you with a platform for you to write that service on. But if you introduce a change and you break something, the onus is on you to go roll that back.
Anybody want to add something to that answer? Or we're all going to sit back and let Netflix carry the cat.
Well, also, so for the integration team that I was talking about earlier, where a lot of the potential breaking of the if there was assembler kind of thing can happen, that's exactly the same way it works. So the ownership is on them, such that it is not it is not them feeling like, oh well, fix it. It's them saying, here, I know this is happening. Here, I know that I should tell you way before I actually release this. And although we do not, exactly who owns the client is a bit more of a shared thing. But the onus of, we are breaking our API, you need to know and fix this beforehand, and we will help facilitate that, is on that team. It's not elsewhere.
I mean, I think version APIs help with that. So you can, I mean, generally, we're getting to the model where we are at this place where each microservices team, or service team rather, just, they don't have to tell anyone that they're updating their code base or their service. If they are introducing breaking changes, again, that onus is on them to either message it to all their client teams and come up with a way to sort of sunset the old service, or create a new version of that service and make that available so you're not breaking clients, right? So all of it is, with sort of great power comes great responsibility, right? You can now push whenever you want, but you are now responsible for everything that you own. So make sure that talk to centralized teams who are really proficient at doing this kind of stuff, have them help you go through this process. But ultimately, your hands are on the wheel. It's your own destiny, right?
If I could paraphrase it, you're responsible for the whole history of your code base, not just the head of the tree. There was a question over here.
I would like to know, how would you do performance testing in a lot of microservices? When you have a lot of microservices, how would you go about actually performance testing your system?
How would you perform testing when you don't have microservices? Does that change?
Yeah,
If you have a monolithic world, you would still, I think.
Well, your dependency is reduced by that.
I'm trolling, but I mean, I think the thing is to realize performance testing. I'm glad you brought this up. Is really important, and we tend to do a lot of it in production. We have a really killer performance engineering team, with some really great subject matter experts, and they're developing a great suite of tools so that you can go into any instance, any container that we own, and do CPU profiling, or inspect the memory, or look at all the metrics that's coming out of that, and sort of really being able to do that in production is really important, because it's at our scale, at sort of the wide range of requests that's come through the system, it's really, really hard to replicate that in a test environment. So whether we were running a monolith or a microservices doesn't really matter. What really matters is making sure that you're building your service with using software and using tools that let you do that sort of monitoring in production. Right?
Performance bottlenecks become harder to find in microservices, right?
Why is that?
But if you don't have traceability, your performance bottlenecks are harder to find, whereas monolith, you can find it easier.
If I don't have what, sorry?
Performance, you don't have traceability? If you don't have traceability.
If you don't, well, I think that depends. There's lots of different axes to look at when you look at performance. You could say like, hey, it takes me. Generally speaking, the performance of a service is usually observed by its latency, right? And so, if you're running a microservices architecture, you better be darn sure that you have visibility into at least the latency characteristics of each service. Otherwise, you're hosed. Don't even think about doing that, because you just have this big black hole. You have 100 microservices in the back end. You have no idea where latency is coming from. So assuming that you have that, that generally speaking is good enough to say oh, it's this specific service that's misbehaving. What you need then is a set of tools to go in and closely introspect that service, and whether that's built into. So a lot of times, right, the problem isn't that you don't have observability. It's, hey, I'm not emitting the right set of metrics for the specific problem that I'm looking at, and in order for me to do that, maybe I have to push the code again. And generally speaking, that's not good enough for us. So we invest in a lot of tools where you can look at performance characteristics and and look at metrics that aren't even there yet. So for example, a good example of this is something called CPU profiling, which lets you profile sort of, this is going to get really technical, but lets you profile exactly what's being run on the stack, sample that, and sort of aggregate it into something called a flame graph, which lets you see how much time you're spending on CPU, for example. But you can do that for everything else as well. But having a set of tools where you don't need to make changes to the software to observe it is really handy. That's what we found. Especially since we have the centralized performance engineering team, they're not going to know the details of any specific service. So when they're being called into action, when there are issues, they're generally speaking almost like a doctor in the ER, right? Someone comes in and they use a set of tools to try to figure out what's going on wrong.
So it actually piggybacks off the last question. What role has introspection played in your ability to adopt microservices and either enabling or hindering your ability to deploy these in production? That makes sense. So the ability to look inside of a process, understand what it's doing and how its behavior patterns are affecting the processes around it, and whether that's a big black box for your organization or how you see inside of it, and whether that's getting in the way of you deploying microservices.
John Paul?
So I don't actually know the tools, and I know that the name is on the tip of my tongue, the Node thing that can do this, some instrumentation that can do this locally. In terms of hampering the ability to deploy, it does not, and it has. I think that there's been I forget the name of the other OS that makes this easier, but there have been attempts to be able to do this after the fact, and it has not stopped. Not being able to do that has not stopped these things shipping, and how, I think as part of the long list of goals around better monitoring, being able to change the culture, and being able to, being better just in general, this is one of them. But it's definitely not stopped anything not having it, and we do have that ability in the rare cases where we have felt it is necessary.
I think the thing you have to remember is actually going to a microservices architecture is ironically much, much harder than it seems on the surface, because you're increasing the scale at which you're operating at, right? So instead of having one support team for one service, you have maybe 100 services, and how do you support all 100 services? And so if you didn't have good metrics to start with, and now you blow that out to a distributed system, you're really in for a world of hurt. So really understanding that, one, it's not a panacea. It's not going to magically solve all your problems. And if you do it wrong, it's actually going to introduce more problems than it solves, right? Because now, imagine a world where you don't have any metrics, or you don't have any of the right metrics. It's you in your monolithic service, and you don't really have a way to look inside. And you say, oh, the way I can solve this is let's just move to microservices. Well, you're just adding complexity, right, without solving the problem. So I think it's a really great question, which is around like, always design any service that you own with that stuff in mind up front, right? So like, think about the worst case scenario. Like, I have a service and for some reason there are issues, right? How do I go about fixing that, debugging it and fixing the service before you go and start cutting code and writing the platform? And if you go into building the platforms with that model in mind, then you'll find that you're naturally building in metrics and logging and stuff like distributed request tracing and failure injection testing and alerts with sort of in situ along with that process of building the platform. And that way, it just becomes part of the platform, and it's a first-class thing. Generally, I've found in my experience, when we've had to strap those on towards the end, back half of the project, it doesn't really go well, right? Because you're like having to retrofit stuff in, and it's not a first-class citizen inside the ecosystem.
It's one of the reasons why we have test embedded in our teams as well, because developers tend to always try to go the happy path way.
Oh, yeah,
it's just our personalities and the way that we work, we tend to go happy path. It's good to have somebody there who's constantly thinking about how this product is going to fail and how they're going to make it fail. And that helps us with our stress testing, ensuring that we've got the right monitoring in for them. So if they start seeing those failures, they know what's causing it as well.
Thank you.
Okay. We've got time for probably one more question from the audience, if there's one more person. No? Am I missing? No? So I have one.
Over there.
Okay.
Hello. So sort of on the question before they were asking about API contracts, how are you all sort of managing the different API contracts that you might have between all the different services? Like, do you have a single place where you're kind of cataloging, keeping track of like the inputs and the outputs expected? Is each service up to their own, and then it gets posted back somewhere? How are you guys keeping track of all these things?
So at the minute we've started using API Blueprint, especially when we're trying to develop APIs at the same time as we're developing the clients that are going to be using them. We've found that it works really well. It's a good way of communicating how the contract between the two things are going to work, and for recording for later generations so that everyone knows how our APIs work.
Embedded, right?
For the latest ones that we've been building. I can't say that all of the things that we've ever done have done that, but it's something that we're moving towards doing.
It seems like everything old is new again. So I mean, a long time ago we had SOAP, which was like version. We had an IDL that defined kind of what exactly what your API was. And then the world will move to REST, which is like, okay, now I'm just going to sort of define some resources and be really less strict at the client perspective of ensuring that the API is correct. But the server itself is going to do a lot more of that checking around robustness and strictness of the API. And I think it seems like, I mean, I've heard a lot of folks at conferences and various places talk about maybe it's time to bring back IDLs. And it's kind of like this sort of, it's all about trade-offs, right? Do you want to move much more quickly? If you want to do that, then obviously introducing the friction of having to redefine an IDL or a version API, it adds to that. But if you want to be absolutely certain that you sort of try to mitigate errors and have a much more reliable service, then you go the other direction. I think the thing that we've sort of been doing is a lot of the new services that we're thinking about writing on our new PaaS platform. We actually have something that's very similar to the NPM registry, but for services. And so everyone sort of, if you're creating a new service on top of the PaaS, you basically release it like almost like an NPM module. You version it, and then you publish it to an index. And there's a major version or a minor version, and then you must respect. Just so typically how like NPM works, you must respect somewhere. If you're a module owner, you must respect somewhere. If you're a service owner, and sort of that we think helps, because in the past we've had kind of each team was taking its own liberties with the way that they would do versions. Some wouldn't version at all. Some would use like a timestamp. It didn't really make sense to have that fragmentation. So we've said, let's just have a first-class way to do versioning. And typically, I think we think Summer is going to work out well for us. I mean, results are kind of remains to be seen as sort of we get more adoption, but that's kind of how we've approached the problem.
Cool.
Okay. I think that's all we have for today in terms of panel discussions. Just a couple of wrap-ups. There are drinks the other side of the building in the gallery. You can go through either hallway. I believe there's still some swag bags to be picked up if people haven't picked up a swag bag. I'd like to say a special thank you to Condé Nast and McKinsey for helping to support and fund this event, and Condé Nast for this amazing venue. We'll see you for drinks, and thanks very much for turning up for what I think was a really fantastic event today.